Okay, so section 1.2, reducing fractions by using the distributive property. So this is going to expand on our ability to reduce fractions, but they're a little bit more complicated now because it will include some variables or a variable in the expression. So I think maybe the easiest way to start before we even look at our example here is to remind ourselves what happens when we add fractions, right? If I have something like 2x over 7 and I'm adding it to 1 over 7, right? Something like this. Hopefully I remember from yesteryear when I'm adding fractions, they need to have a common denominator. So in this case in orange, they have a common denominator, right? The 7s are the same. So when I'm adding fractions together, in this case I add the tops and they end up over the same fraction. So if the fraction, each of those terms had a different denominator, we'd have to make them common. We'd have to have a common denominator, and we looked at how to do that last week. But for right now, I want to just kind of keep it simple and look at something like this. So what we started here with 2x over 7 plus 1 over 7, we were able to combine those terms and put them over one denominator because it had a common denominator. What we're doing in this section is really working backwards. We would start with something like this and ask you to split it apart. That's really what we're doing. And it's pretty easy to do, actually. You can see all we did was take the first term and put it over the 7, and then take the 1 and put it over the 7, and we split it up. That's all we did there. So this example here, kind of again, it shows why this works. Right, it's really using the distributive property, right? If I think of what, just kind of stick with this example here. If I think of what 2x plus 1 over 7, right, would be equal to, that would be equal to taking 1 over 7 and multiplying it times 2x plus 1, right? So I'm kind of factoring out the denominator, and then I'm multiplying it back through separately. Right, so that's kind of complicated, I think. So we're going to kind of focus on the easiest way, the simplest way to do these, and that's really to just split them and then reduce. Right, so if I look at this example right here, instead of going through this whole process, right, I think if we just take our original expression, and I don't know, the classes of other years have kind of thought about doing this, like making it a butterfly for some reason. That seems to kind of stick in people's memory, and then I split it up. So I would end up with 15x over 25, and then I'm subtracting, I split it up, 5 over 25. Right, so I'm just splitting it up, and then I'm going to reduce, just like we did in section 1.1, by finding a common factor. Right, I see that 5 goes into each of these, so I would end up with 15 divided by 5 is 3x over 25 divided by 5 is 5. And the same thing with this term here. If I divide each by 5, 5 over 5 is 1, 25 divided by 5 is 5. And I can see that's the same thing I ended up with here. So hopefully I didn't confuse you too much. We have a couple, 4 or 5 examples here, and really with that method, it's going to go really fast. So I'm going to go ahead and kind of just start applying our method, and we'll see. So completely reduce, we're going to go ahead and we're going to identify the two terms that we're going to end up with. So I have a 4x over 3. Oops. And I wrote over my sign so you couldn't see what it was. It was a minus sign. So minus 16 over 3. So we successfully split it into two different terms, but I cannot reduce this any further. 3 does not have a common factor with 4, nor does 3 and 16 have a factor. So that's all we can do. Right? So we go down to this one. Again, I'm going to do like I did on the last. And I'm going to make it bigger so we can kind of see what's happening. So I'm going to identify what the two terms will be. It's going to be these guys. And I will end up with, right, that's going to simplify to 11 over 6 plus 3x over 6. So I split it up. 11 and 6 do not have any common factors, but these guys do. So I would end up with 11 over 6 plus 3 over 3 divided by 3 is 1, so 1x, or just x would be okay, and 6 divided by 3 is 2. So that's our simplified one there. When I come down here, 15, again, I'm just going to write it because those are a little bit small. So if I take that term right there, or that expression right there, and split it into two terms, I would end up with one here and one there. I'm going to keep the same sign in the middle. So I would end up with 15 over 12 plus 6x over 12. 15 and 12, they have a common factor that would be 3. So I'm going to go ahead and actually do this one without writing our little division sign. We want to progress to the point where we don't have to write that every time. If you still need to do that each time, that's okay. I'm going to try and maybe do it without it so much here for these last couple. So 15 divided by 12, 3 goes into 15 5 times, 3 goes into 12 4 times. And over here, 6 and 12 each have a common factor. 6 goes into 6 once, and 6 goes into 12 2 times. Okay, D and E. So, again, just to make it a little bit easier to see, I'll write it a little bit bigger. Oops. 4 minus 2x over 8. And if I split it into two terms, that'll be one, that'll be the other, and we'll keep our minus sign. So that would be equivalent to 4 over 8 minus 2x over 8. And again, trying to kind of wean ourselves off of doing the little symbols in there and just do some mental math here. 4 and 8, the common factor would be 4. So 4 goes into 4 once, and 4 goes into 8 twice. And over here, 2 and 8, 2 goes into 2 one time, and 2 goes into 8 4 times. So we're just kind of using our little butterfly method to split it apart and then reduce the fractions as needed. You can see some of these, they end up, so as I look through these again, our first one, we couldn't reduce it at all after we split it. Our second one, we could only reduce one of them. Our third one, we reduced 2 of them. And we did the same thing on our fourth one, and those actually ended up, because they had different factors, multiplying, or the denominators ended up being different for the two terms. All right, so just split it apart and then do whatever it tells you to do. And our very last one here, 40, whoops, what happened there? 42x minus 14 divided by 7. So if I go ahead and split it into my two terms, 42x over 7 minus 14 over 7. And here, this actually works out pretty good because 42 in our first term, 42 and 7 each have a factor of 7. 7 goes into 42 evenly 6 times. All right, so if I think about what 42 divided by 7, right? That is a 6, so I end up with a 6x, and 14 divided by 7 is a 2. Right? So sometimes I can actually just divide, and if I end up with an even number, that's the easiest of all. Right? So 7 goes into 14 twice, and 7 goes into 7 once, so it would be 6 over 1x, so the 1's going to drop out. So that's what we got for this section here. Those weren't too painful, I hope. It's really not as complicated as this original example kind of makes it look. I want to, again, always illustrate why these things work and try and teach you those things. You can see it used common factors just like we did in reducing regular fractions. I think what's best practice is to show you guys why things work, but then really focus on how to execute the solutions. It's not always important to memorize the theory, but really know how to apply what is discovered by through those theoretical solutions. So, okay, that's what we got for this one.